Welcome back to the deep dive. Today, we are strapping in for a truly mind-bending journey. We're going to ask a massive question. What if the bedrock of modern physics, Einstein's special relativity, missed a fundamental, maybe even a psychological step?
It's a huge challenge to the standard model. And we're diving deep into a critique that argues the very space you perceive around you right now. It's a simultaneous plane.
It's a blend of different past moments.
Exactly. And the sources we're looking at, they're unique because they don't just, attack the math. They introduce entirely new structural concepts.
This is the Zionad chat model, right?
It is. And it draws on structured philosophy, geometry, and, surprisingly, Lacanian psychoanalysis.
All visualized with modern tools like Blender and even AI analysis. It's quite a mix.
It is.
Okay, so let's try and unpack this. Our mission today is to really get our heads around this core idea they call temporal thickness. Because if our perception of space is just an accumulation of information from different times, what does that even do to our concept of now?
It shatters it, really. And we'll get into the tools they use to explain it. There's a high-speed train, some very specific camera setups, and even a vintage World War II bomb site.
A bomb site. Okay, I'm intrigued.
It's a great analogy. But first, to really understand the fight, we have to define the two opposing camps.
Right.
So you have Camp A, which is the standard Einstein perspective. This view focuses almost entirely on internal consistency.
Meaning, as long as the physics works the same inside your own little bubble, you're good.
Precisely. If you're on a train, moving at a constant speed, you just treat that train as your fixed universe, and the math all checks out inside that frame.
And the tool that lets you do that is the Lorentz transformation.
Exactly. That's the key.
Yeah.
The Lorentz transformation treats space and time as mathematically adjustable, like an elastic container that stretches and shrinks.
Time dilation, length contraction, all that stuff.
All of it. It all works to keep the speed of light, c, a constant within that moving frame. It's a very elegant self-contained system.
But Camp B, the Zionad chat model, says that's a fundamental error.
It says that's missing the forest for the trees. Camp B focuses on external consistency. It asserts that the electromagnetic field, the EMF, is the single, absolute, non-deformable physical medium.
The stage for everything.
The one and only stage where light travels at sea. They even have a specific term for it from the sources. Ziench.
And that means?
It translates to the site or the scene.
So it's not just an abstract field, it's a physical location.
Yes. It implies a fixed, undeniable stage upon which all events, all motion unfolds. And crucially, all movement, including your own as an observer, has to be calculated relative to it.
The argument being that Einstein just skipped over this?
They argue he chose the mathematical convenience of internal frames over the physical reality of this absolute medium.
Wow. Okay, that distinction, that changes everything.
It does.
Because if the EMF is the absolute medium, then the geometry of the universe isn't defined by our convenient little mathematical frames.
It's defined by how light physically moves through that medium, which brings us right to their thought experiment.
All right, let's get into the setup. This is designed to force the issue, right? To make us confront the physics of observation.
It is. So imagine a big, controlled environment, a cube, 60 by 60 by 60 units, and its center is at the origin, so 0, 0, 0.
Okay, a big box.
Inside that box, run right along the x-axis, is a railroad track.
And on that track, we have our object, a high-speed train.
A very specific one. It's a line segment train with a length of exactly 4 units.
And at the moment we start our clock, at time equals 0.
At t0, that train is positioned right in the center, from x equals -2 to x equals +2. And this is the critical part. It's moving fast.
How fast?
10% of the speed of light, 0.1 c, heading out towards x equals 100.
So the event we're actually observing is the light that's emitted from every single point on that train, all at the same instant, at t0.
Yes. And that light is then collected by a whole bunch of cameras.
Camera eyes, as the source calls them. And they're placed on the surface of that big 60 by 60 cube.
And also there's a second set of cameras. This is a really key detail.
Okay.
There's a sphere inscribed inside the cube.
Yeah.
Its radius is 30 units, also centered at the origin. And there are cameras all over the surface of that sphere too.
All right, now here's where it gets interesting for me. Why both? Why a cube and a sphere? That seems redundant.
Well, this gets back to that whole mathematical convenience versus physical reality thing.
Ah.
The sources hypothesize that the spherical arrangement is just, easier to normalize.
What does that mean here?
Think about how light works. It radiates outwards from a source, in all directions, right? Spherically. So a spherical coordinate system is much more natural for describing electromagnetic phenomena.
So the sphere respects the physics of light propagation, while the cube just imposes this arbitrary grid on top of it.
You've got it. But whether it's the cube or the sphere, the goal of all these cameras is the same.
To capture the light from that teaser event from lots of different positions.
Exactly. You've got camera A way over on the axis and camera B way out on the x-axis. And they record not just the direction the light came from, but also their separate arrival times.
And that's the whole game right there, the different arrival times.
That's the data you need. Because the Cyanide chat model says the EMF is the absolute reference.
The do.
Did you?
What?
And we know the speed of light in that medium is constant, and we know the exact position of every single camera. So the differences in arrival time become a solvable geometry puzzle.
I can work backwards.
You can reverse calculate the object's true emission position, P, and its true emission time, T.
You're triangulating its position in space-time. This is literally how GPS works. It uses time-delay geometry.
It's the exact same principle. So what here is that this whole setup forces you to admit that observation isn't just passively receiving a now.
It's an active decoding of delayed signals, an archaeological dig.
Which means we have to completely redefine what we mean by space. If every observation is delayed, then the space you perceive isn't the simultaneous plane of Einstein's model.
Instead, it's that phrase again, an accumulation of information from different times. It's temporal thickness.
Yeah, and there's a great way to visualize this. Think about a standard Minkowski diagram, space versus time.
The Hess light cone.
Right. Normally you see it as a smooth cone. Yeah. But this model says you should picture it as infinitely stacked rings or toruses.
Okay.
The tip of the cone is you, right now, at T00. A ring halfway down the cone, say at a radius of 10, that represents all the light that was emitted at time T=-10.
So the spatial radius of any ring on that cone is directly tied to how long ago the light left its source.
Precisely. Your perception of spatial depth,
Mm-hmm.
it's fundamentally equivalent to the physical length of time that light traveled to reach your eye.
So when I look across the room, I'm seeing the wall as it was a few nanoseconds ago.
And you're seeing the moon as it was over a second ago.
At the same time.
At the same time. Your brain is getting all this data from different moments, and it performs this incredible processing job to create the illusion of a single, unified now.
So my perception of space is a reconstructed paste up.
A paste up of all those different past moments, which is why that Norden bomb site analogy is so powerful.
Right. Tell me about the bomb site. How does that fit in?
It's a perfect real-world example. The Norden site was this incredibly complex optical computer used on U.S. bombers in World War II, and the 2D screen the bombardier looked at.
It was showing an image from the ground.
An image formed by light rays that had left the ground at dramatically different past times because some parts of the ground were further away than others.
And the bomber itself, the observer, was moving incredibly fast through the air, or in our case, through the absolute EMF.
Yes. So the light rays were delayed, and they were also subject to deviation or aberration. The Norden site was a practical physical device that had to account for a time-thick projection to work.
It had to solve for the delay.
It had to. The Einstein model, by contrast, is more like a timeless trick picture, like taking a screenshot in Blender. It assumes instantaneous projection and just ignores the physical travel time of light.
And if you ignore the delay, you're ignoring the entire physics of the situation.
You're ignoring the observation itself.
Okay, this brings us to the really deep and, I guess, more controversial part of this, the psychophysical link. Why would a model that ignores this physical delay persist for so long?
Before we get to the why, we have to look at the what, the core physical misunderstanding. And it centers on how we treat light aberration.
The apparent shift in a star's position because of the Earth's motion.
Right. Mainstream physics just treats that as a mathematical outcome of the Lorentz transformation. It's just a coordinate shift.
But the Cyanide model says no, it's a real physical process.
A physical process that requires what they call deviation shooting.
Like leading a target.
Exactly like leading a target. Think about ballistics. If you, the observer, are moving quickly through the absolute EMF, you have to aim your camera or telescope at the target's predicted future position.
Because in the time it takes the light to cross the EMF to get to you, you've moved.
You've moved. You have to shoot where the duck is going to be, not where it is now.
The high-speed light clock example they use really makes this clear.
It simplifies the whole principle beautifully.
Yeah.
So imagine that train moving at 0.1 c. Inside, you send a pulse of light from the floor at Z0 straight up to a sensor on the ceiling at Z10.
Naively, you'd think it takes 10 units of time.
But if you're calculating from the perspective of the fixed EMF, the GRE, it can't possibly hit the point directly above, because in the time the light was traveling up, the ceiling has moved horizontally.
So the light has to be aimed forward at a slant.
That's the deviation shooting.
Yeah.
It has to be aimed to intercept the ceiling's future position. The standard view just kind of assumes the light magically inherits the train's forward momentum.
But the Chat model says that's impossible. Light only obeys the speeds you see in the absolute EMF.
Correct. And because it travels along that longer slanted path, the time it takes is measurably longer. It's a physical difference, not just a mathematical one.
Okay, that shift from math back to physical ballistics is huge. And this is where the psychoanalysis comes in to explain why this was rejected.
Yes. The sources describe the Einsteinian perspective as a form of narcissism. And they're using a very specific definition from Lacanian psychoanalysis.
An attachment to the imaginary. How does that apply to physics?
Well, in Lacan's terms, the imaginary order is all about identifying with your mirror image, a perfect, stable, whole version of yourself.
So, by clinging to your own coordinate system and declaring, I am standing still, the observer is
Treating their own inertial frame as that perfect, privileged mirror image, the center of the universe. They ignore the external reality that they are objectively moving through the EMF, because admitting that would shatter the illusion.
So the Lorentz transformation becomes a mathematical way to justify that self-centered fantasy.
That's the argument. The refusal to calculate your own objective motion relative to the EMF is a refusal to admit you are not the center.
And the alternative?
The Chat model demands the observer move into what Lacan called the symbolic order. To do that, you have to admit, I am just a data receiver moving within the absolute EMF.
This is where that term castrated comes in the psychoanalytic sense.
Not literally, of course, symbolically. The observer has to be castrated from their privileged central position. You have to accept the Father's law, the external absolute reality of the EMF, which imposes objective distance and delay on everyone.
It's an intellectual submission to an external reality rather than a self-referential bubble.
Exactly.
That is a staggering way to frame a physics debate, to argue that a model persists because of a structural reluctance to decenter the self.
It turns a math problem into a deep philosophical critique of how we observe the world.
So let's bring this all home. The core structural difference is clear. Einstein's model relies on simultaneous planes and internal consistency. We'll call that A.
While Chat's model, B, emphasizes the EMF as the absolute site, which demands we account for temporal thickness and use information geometry to reverse calculate events.
And this difference isn't just on paper. It has physical consequences, like the need for deviation shooting.
And the ability to use multiple cameras, like a sophisticated GPS, to actually prove the geometry of delay.
Now, to test these two conceptual models, the sources did something really interesting. They submitted the premises of both A and B to multiple generative AIs.
Yeah, Gemini, ChatGPT, Claude, Grok, the big ones.
And the results were pretty lopsided.
Overwhelmingly so. The AIs favor the Chat model, Model B, with support ranging from 70% to 95%.
That's a massive preference. We have to ask why. Why would these pure logic engines favor Model B so strongly?
I think it comes down to what they are. They're information processing systems. And Model B's description of observation as information delay, reverse calculation, the geometry of signals, it aligns perfectly with the logic of information processing.
Model B treats reality as a data problem that you have to solve. And since the AIs themselves run on information architecture and causality,
they naturally validate the model that prioritizes signal time and data geometry over a kind of localized mathematical smoothing. The AI, operating outside our human narcissism, sees the absolute external consistency as simply more rigorous.
This whole deep dive really challenges what it even means to be present. So here's the final thought. If our concept of space is merely a 2D projection, a collection of different moments from the past, and the act of observation is just a complex archaeology of information delayed across the electromagnetic field, does the idea of a truly simultaneous reality even exist? Or is our entire perceived present just a meticulously integrated function of memory?